Today's lecture is an introduction to transformations, and we're going to be just learning some vocabulary terms and becoming familiar with the three main transformations so that we can work successfully on our projects coming up. So for today's purposes, I just want you to write down the definitions and then make sure you understand how each one works. There will be a book assignment in class, and it's just to give you a little bit of practice before we start working on our projects. So some vocabulary terms. A pre-image is what the original figure looks like before it is transformed, and the image is the new figure after the transformation or transformations. A transformation itself is an operation that maps or moves the pre-image onto the image. And we'll talk about three main transformations today in the lesson. Isometry is a transformation that preserves length, angle measures, parallel lines, and distances. And all three of the transformations that we will deal with are all isometries. And then a rigid transformation is just a transformation that is an isometry. So all of the transformations we deal with are all rigid transformations. The first type of transformation is a reflection, and a reflection uses a line that acts like a mirror with an image reflected in the line. And the line is called the line of reflection. And you can imagine these lines as mirrors. So for our first example down here in the corner, we have point P that is reflected over the line here. So the red is our pre-image, it's what we start with, and the blue is our image, it's what's happened after the transformation. So we start on this side of the line, then it's reflected over the line. And I've used a different color just to help indicate before and after. You'll also notice that the original point was named point P, and the new point after the reflection is P prime. The prime just indicates this is what's the result of a transformation. Here's another example of a reflection with a triangle, and the red and the blue are again just to indicate before and after. So we have our red pre-image here. It's reflected over the line. And we have our blue image after the reflection. And I've put a little point down in the corner so that you can see that it's simply just reflected over the line. You can see that the point is away from the line and down. If you look at where the point is on this triangle, it's also away from the line and down. And then finally, I did this last one freehand, so it's just the number 4, and it's reflected over the line. So you can see how it looks like its mirror image. The next type of transformation is a rotation, and a rotation is a transformation in which a figure is turned about a fixed point or a center of rotation. Sometimes the center of rotation is right on the object or the figure, and sometimes it's not. So here are some examples of rotations. We have the letter F here in red. This is our pre-image. And you can see down here is our center of rotation. So I've got a little line extended from the center of rotation to the figure so that you can see the angle of rotation. So this F has been rotated about this point down here through this angle of rotation, which is, I don't know, maybe 15 degrees. And then the blue F is the image after the rotation. A little bit easier to see is when a rotation happens about a point that's actually on the figure. So you can see here the red triangle is our pre-image, and the blue triangle is what has happened after this figure was rotated about this point here. Hopefully you can imagine that this figure has kind of been rotated in this direction to it almost looks like it's been flipped this way. So our center of rotation here is the point, which means that point stays still as the figure rotates. To add to this, we also have what's called rotational symmetry, and a figure, if it can be mapped onto itself by a rotation of 180 degrees or less, we call that rotational symmetry. And a good example of that is just a square. I've highlighted just one of the sides in red so that we can kind of follow that figure as we rotate it. But notice when you change a square, when you rotate a square 45 degrees, this is not mapping onto itself. That means if I were to pick this, now it looks more like a diamond, but if I were to pick this up and place it on the other square, they don't line up. But if I turn it another 45 degrees, or if I'm turning the original square 90 degrees, the image or the figure, if I were to pick this up, I could place it right back on top of itself. This is called rotational symmetry. And then I continue to rotate the object another 45 degrees, and then finally another 45 degrees for a full 180. And you can see in the ones I'm starring that the square has rotational symmetry because those three with stars in them all line up. And I've only highlighted the red part just so that we can kind of follow what it looks like when you turn the square. Finally, we have the transformation that's called a translation. And the definition, the technical definition is pretty fancy, but what it says is that a transformation that maps every 2 points, P and Q, in the plane to points P prime and Q prime, so that the segment P, P prime, and Q, Q prime are equal, and they are also parallel. And this is really just a very fancy way to say a slide. So you can see in our example here, I've labeled 2 points on the figure P and Q, and after the translation, I've labeled them P prime and Q prime. What this says is that P prime here, P, P prime, and Q, Q prime must be equal in length, and they are. So we can draw little congruent marks on them. They also need to be parallel, and you can see by this picture that they are, and I will also mark them parallel. So it's really just talking about the connecting segments. You can see this figure, our pre-image, has been slid to the right for our blue image. Very similar on the next example, we've got our red triangle as our image. If I label this point P, then the point here on top of the triangle will be P prime. And if I use the bottom corner for Q, then here we would have Q prime. And you can see that the triangle has just been slid down and to the right. And if this will be freehand, but if I draw a line here that connects P and P prime and Q prime, they are congruent and they are also parallel. So remember, today was just an introduction to transformations. I want you to be familiar with rotation, reflection, and translation. We are going to work on a book assignment tomorrow in class, and this is really just to give you some practice. It looks like a lot of problems, but notice that the majority of these are evens. So please make sure you bring your book to class tomorrow, and we'll get through the assignment and then be able to start our projects.